Let us examine word problems that lead us to composing functions. We're going to just take a quick review of composition of functions, and then we're going to look at the steps we follow when we deal with word problems that lead us to composing functions. So when we look at the composition of functions, what we're saying here is that if f of x is equal to p and g of x equal to q, then f o g of x, which is equal to f of g of x, is the same as f of q, and g o f of x is equal to g of f of x, which is the same as g of p. Now we're going to look at some examples to show this. So f of x is 3x plus 2, g of x is 4x. What are the values of f o g of x? So let's look at f o g of x is going to be f of g of x. So this is going to be f of 4x. Now what we're going to have here is, for f of x, where we have 4x, wherever we have x, we're going to replace with 4x. So this is going to be 12x plus 2. G o f of x is g of f of x, which is equal to g of 3x plus, and we're going to have 4 multiplied by 3x plus 2. So this is going to give us 12x plus 8. Now let's look at f o g of 3. So f o g is going to be f of g of 3. So we're going to look for g of 3. G of 3 is equal to 4 times 3, which is 12. So now we're going to look for f of 12, which is equal to 3 times 12 plus 2, which is going to give us 36 plus 2, which is 38. Then g o f of minus 1 is g of f of minus 1. So let's look for f of minus 1. This is going to give us 3 multiplied by minus 1 plus 2, which will end up at negative 3 plus 2, and we get negative 1. So now we're going to look for g of negative 1, which is 4 multiplied by negative 1, which is equal to 4. Negative 4. So to deal with word problems that lead to composing functions, first we're going to have at least 2 functions that we can derive from the question, and then we're going to compose the functions to fit the questions asked. Now let's get started with some of these examples. So a salesperson is given a 20% commission on sales over 250,000. Create a function f of x to identify the commission if the sales are over 250,000. And we create a function g of x to identify the amount of money the commission is earned on. So f of x, the commission is earned on sales over 250,000, but the commission percent is 20%, so this is going to be 0.2x, where x is the amount of money the commission can be earned on. And then g of x is to identify the amount of money the commission is earned on. So we can only earn a commission on sales over 250,000. So we're going to have x minus 250,000. That means that x is the sale over 250,000. So if the salesperson has sales worth 400,000, what function will be used to calculate the commission earned? Okay, so the commission earned, that's an important step. So commission earned is equal to 20% of sales over 250,000. So the first thing you want to find out is, you want to find out what is the amount of money that he can earn a commission on. So it's going to be X minus 250,000. So that's the amount of money he can earn a commission on. And then what is the commission he earns? 0.2 of this. So what we see here is that our composition now, let's call this M of X for the amount of money he earned, is going to be, we can see here that the inner function is g of x, so it's going to be g of x is the inner function, and then f of x is the outer function. So which is the same as f o g of x. So let's simplify this. So we have f of x minus 250,000, which is equal to 0.2 x minus 250,000. So we have 0.2 x minus 50,000. So now the person has sales worth 400,000. So how much commission did the person earn? So M of 400,000 is going to be equal to 0.2 times 400,000 minus 50,000. So 0.2 times 400,000, that should give you 80,000. Then we subtract 50,000, and now we're left with 30,000 as the salesperson's commission. A customer received a 10% off coupon in the mail. At the store, all customers receive a 15% discount. Create a function f of x that represents the effect of the mailed coupon. So the mailed coupon is 10% off, so the user would only pay 90% of what they purchased. So f of x is going to be equal to 0.9x. Create a function g of x that represents the effect of the in-store discount. G of x, so the user is only going to pay 85% of what they of the value of the item purchased. So this is going to be 0.85x. Now, if the store allows its customers to use the in-store discount before using the mailed coupon, what function will best represent this store policy? So we want to use the in-store discount first, so we're going to have 0.85x before we use the mailed-in discount. So 0.5x is used first, and then 0.9x is used thereafter. So this will be represented like this, 0.85x. Okay, so now we want to find out the function. So let's do that. We have 0.85x represents g of x. So we have g of x happens first, and then f of x happens thereafter. So let's call this S of X for the amount of money spent. So this is the same as FOG of X, which is going to give us FOG of X is F of, so G of X is 0.85x, so we have 0.9 multiplied by 0.85x. So this is going to give us 0.765x. Now, if the customer purchases items worth $150, how much will the customer pay the store based on this policy? So S of 150 is equal to 0.765 multiplied by 150. So let's look at this. You can either use a calculator or you can do it with, manually. I like to do it manually, just that's the approach I prefer. So we have 0.765, then we multiply by 150, so we have zeros all over the place. 5 times 5, we have 25, we bring 2 up here. 6 times 5 is 30, we add 2, 32, and then 7 times 5 is 35 plus 3, we have 38, and then let's append a 0 here. 5 times 1, we have 5, 6 times 1, we have 6, 7 times 1, we have 7. We're going to append zeros all over here. So this is 0, 5, 2 plus 5, 7, 8 plus 6, 14, 3 plus 7, 10, with the 1 carried over, 11. And so we have 3 decimal places, so we count 1, 2, 3. So customer is going to pay $114.75.